Hi, I'm Phil McCaffrey, and today's lesson is on reflecting slope lines, slope of a line. So let's take a look at a line here, and we're going to have line L. Where are we going to put line L? Let's put line L just like we did on the last video, and let's label it line L. And line is a linear function. All the points fall on a line. And what happens when they ask us to reflect a line? Well, when we reflect a line, it's making a mirror image of the line. So let's give line L an equation, and this is going to be y equals 2x plus 3. I know the slope isn't 2, but bear with me. So we're going to reflect y. What's the line L? What is the reflection of line L about the y-axis? To reflect a line about the y-axis, you move the line to the intercept point. And so now we have a line that is at the intercept point. I'll get it there. There we go. Okay, so now this is the reflection of line L. This is line L reflected, just like we put it in a mirror. What's the equation of line L when it's reflected about the y-axis? When you reflect about the y-axis, you change the slope negatively, but keep the y-intercept. So this is a y reflection. How about if we change it about the x-axis? Let's choose blue for that. And we're gonna spin this bad boy around, and we're gonna change it about the x-axis. And so now I've got this line, and it's going to bounce off the x-axis, and it's like the sun came out and bounced the line off of the x-axis. So here we come down, and we come all the way down the x-axis and bounce off. So this is an x reflection. And you can see they're both like mirrors. So if I have an x reflection, what do I do down there? For the equation, I keep the same numerical value of the slope, but change its sign. So y equals negative 2x. But notice I've changed the intercept, and all I do there is change the sign. It goes in a proportional basis from above or below the x-axis because it's reflected about the x-axis. So that is reflection about the x-axis. What happens when we have absolute value? Notice y and x reflections are parallel, and that the only difference is this sign change, positive or negative. They are not perpendicular. Reflected lines are not perpendicular in all cases. The only case is perpendicular. The only case that they are perpendicular is if the slope is 1 or negative 1. How about absolute value? How about we erase all this mess I just made? And you could play the video back again. Well, what's the absolute value of a line? I'm going to pull a couple of these lines out of here. The absolute value of a line goes like this. It only bounces off of the x-axis. It has no y value, negative y values. So this equation becomes y. So our original was, what do we say? Y equals 2x plus 3. That was the original line over here that went down. When y is equal to the absolute value of 2x plus 3, we only have positive values for y. And so it is very much like this one, negative 2x plus 3, this line would be, isn't it? It's a negative slope. It's very much like a y reflection without any, is very much like an x reflection without any negative values for y, because we cannot get a negative value out of an absolute value. What is the smallest value of an absolute value? 0. Trick question on the SAT. Are all absolute values positive? No. The absolute value of 0 is 0. So at this point, the line intersects the x-axis, but then immediately goes back up. So this is the equation of the absolute value of a line, and this line is negative 2x plus 3. I'm Phil McCaffrey. Thanks for listening.